Alright, number 25, the limit when x is approaching to 0, e to the x minus 1 minus x over x squared. As usual, always plug in 0 into all the x first to see what we get. So here we will get e to the 0, which is 1, minus 1, which is 0, and then minus 0. All together on the top, you get 0. Over, when you plug in 0 here, 0 squared is of course 0. So in this case, it's 0 over 0 situation. We can use L'Hopital's rule. L'Hopital's rule. We can use it right here. So L'Hopital's rule, okay. That means I can differentiate the top and then differentiate the bottom separately, and then we will continue with our limit. This is the same as the limit when x is approaching to 0. Alright, take the derivative of e to the x is just e to the x. The derivative of negative 1 is 0. The derivative of negative x is minus 1. Right? And then on the bottom, take the derivative of x squared. That will give you 2x. And now you see that we reduce the equation to this function only, right? And once again, we are going to plug in 0 into all the x to see what we get. If you plug in 0 here, you get e to the 0, which is 1. 1 minus 1 is 0, over 2 times 0. This is once again a 0 over 0 situation. And in fact, we can apply L'Hopital's rule again, right? We can apply L'Hopital's rule as many times as we needed to, especially when you see that the expression is getting easier and easier, all right? So now I will just differentiate the top and then differentiate the denominator separately, and then hopefully will be done after this step. Still, we have the limit when x is approaching to 0. On the top, the derivative of e to the x is just e to the x. The derivative of negative 1 is 0. And on the bottom, take the derivative of 2x. That will give you 2. And now, let me plug in 0 into x and to see what we get. We will end up with e to the 0 over the bottom is just a 2. And e to the 0 is just 1 over the bottom is still 2. And when we end up with a nice number, this number will be your nice limit of the original limit.